electrolytic cell. This question has been arise for 2 marks. So last class we have seen Daniel cell, and also we have seen the electrochemical cell. We have seen certain basics of electrolytic cell. Daniel cell we have seen. We have seen the salt bridge. Okay. So today we are going to start with a new session. The question is for 2 to 3 marks. Write the difference between electrochemical cell and electrolytic cell. Okay. So always in exam, write down in this manner. Do not write down first electrochemical cell, then electrolytic cell. So here we will start the question. Okay. So first point. See, electrochemical cell. First point always you give of principle. You know what is the principle of electrochemical cell? So we have seen that it will convert into chemical energy into the electrical energy. So we will write down here. It is a device which converts chemical energy into electric. Yes sir? You can write down along with me. Next come electrolytic. So what was the principle? So it's a device which converts what? It converts electrical energy into chemical energy. So it's a device which converts electrical energy into chemical. You getting it? Okay. Next one. What came the next point? See here, I told you in electrochemical cell, the flow of electron is from anode to cathode. So in the electrochemical cell part, there is a flow of electron from anode to cathode. So here it will be reversed. It will be from cathode to anode. So the flow of electron from anode to cathode. Yes or no? Here the flow of electron is from cathode to anode. Here. So last class we have seen in electrochemical cell there was a zinc was an anode, copper was in cathode. So electrons were transferring from zinc to copper. So zinc was acting as anode, copper was acting as cathode. The flow of electron is from anode to cathode. Where? In electrochemical cell. So electrolytic cell will be reverse. So in electrolytic cell, the flow of electron is from cathode to anode. One more point I told you. In electrochemical cell, the electrons are coming from anode and they are going towards cathode. So anode was considered to be negative charge. Yes or no? So here anode will be negative and cathode was positive. Yes or no? Because I told you the electrons are coming from anode. So to remember that from the place where the electrons are coming, so that place or that electrode we are considering as an anode, and that part the sign is considered to be negative. So similarly cathode will be positive. If you do the reverse case here you can see anode will be positive and cathode will be negative. Why? Because the flow of electron is reversed. So when flow of electron is reversed, so one here in electrochemical cell, one who is acting as anode, they will act as a cathode, and here one who is acting as a cathode, they will be acting as a anode. Clear? Next point. Next point can be, I told you the work is spontaneous. Yes or no? Here no extra force is required. Where? In electrochemical cell. As soon as you join the circuit, the electron starts to flow. So here the work is spontaneous. Work is spontaneous. So here extra electric work is required. I have to supply the electric current. So your work is non-spontaneous. Yes or no? Why? Because here extra work I have to supply the electric current. If I supply the electric current, then only this cell will work. Without supplying of electric current, this electrolytic cell will not work. Whereas electrochemical cell, as soon as I take one anode, one cathode and I connect the circuit, as soon as I connect the circuit, the flow of electrons starts. From where to where? Anode to cathode. So this is spontaneous. Means it starts to do the work of its own. The flow of electron starts as soon as I connect the circuit. But here is not the same pattern. Here what happens, I have to supply the electric current. If I supply the electric current, then only this electrolytic cell will start. That's why I am telling here what? Work is non-spontaneous. Fifth, as you have studied in thermodynamics, if work is spontaneous, means delta G here, delta Gibbs free energy will be less than 0. So here it will be what? Free energy will be greater than 0. This you have studied in the standard 11 thermodynamics. Okay, so your work is spontaneous. So delta G 0 for electrochemical cell always will be less than 0, whereas delta G 0 will be greater than 0 for electrolytic cell, because your work is spontaneous. So delta G will be negative. That's why less than 0. Your work is non-spontaneous. That's why delta G 0 means work is non-spontaneous, means your free energy will be positive. So delta G 0 will be greater than 0. Next. Okay. See here. Next point can be, last class we have seen that on anode oxidation occurs, because anode capacity in electrochemical cell is loose. We have seen Zn was converting into Zn plus 2 electron. So in electrochemical cell, the anode is having a capacity to undergo oxidation. So whereas cathode reduction, here it will be reversed. So first we will see here, so anode will undergo oxidation and cathode will undergo reduction. Clear? The next point you can write down, reverse here, 5, 6. Here what you will write down? See here, electrochemical cell, anode will undergo oxidation. So here anode will undergo reduction. Yes or no? And cathode will undergo reduction, oxidation. The thing this point it's might bit confusing to you. See here, in electrochemical cell, in Daniel cell, we have seen that zinc was acting as anode and zinc was losing its 2 electron. So zinc was acting as an anode. Okay. So losing 2 electron means what? Oxidation. That's why here I told in electrochemical cell, anode will undergo oxidation. So similarly, if anode is going oxidation, so cathode will undergo reduction. So electrolytic cell will be what? The point are reversed. Here anode is oxidation, so anode will be a reduction, and similarly cathode will be a oxidation. Okay. The next point you can write out here, 7th point, cooperative. Okay. You can see the here example. What is the example here? Daniel cell. Best example is one. Or you can say volatile cell. Here example can be what? I can say recharging of battery. Yes or no? And obtaining of metals. Obtaining of metals. How? You will understood in the metallurgy. See, to obtain the metal from certain ores, I have to supply the current. I have to supply what? I have to supply the current. So recharging of battery and obtaining of metal. Okay, remember these points. You can write on it. Okay, one more important point, that is, I forgot to tell you. See here, remember very important point and very basic point. In electrochemical cell, the circuit was not completed without salt bridge. Yes or no? So in electrochemical cell, salt bridge is required. So electrochemical cell, salt bridge is required. I hope you remember. See, in electrochemical cell, what we are having? We are having one anode compartment, one cathode compartment. Then we have connected the battery. Sorry, we have connected both the anode and cathode by conducting wire. Initially, current was flowing, but after some time, due to the imbalance of charges, current stops to flow. So we have inserted one salt bridge. Where in electrochemical cell, as soon as I inserted the salt bridge, current starts to flow. Means in electrochemical cell, salt bridge is compulsory required. But here, salt bridge is not required. Okay. One more point you can add, which is not so important, but for getting the knowledge, you can add one more point. The point is, see, in electrochemical cell, there were two different compartments. Yes or no? In electrochemical cell, one was anode and another one was cathode. But in electrolytic cell, there is no different compartment. One compartment itself you can make the electrolytic cell. So here, two different compartments are required. Okay, and here no different compartments are required. So this can be certain basic difference between what? Electrolytic cell and electrochemical cell. Very simple, you can understand. And see, it's a question near about 2 marks. If 2 mark question is coming, you can write down maximum 5 points. Don't write down this much, don't waste your time in the exam. Okay, so you can copy out. See, this point is very important. Electrochemical cell work is spontaneous, your work is non-spontaneous. Due to this reason only I told you delta G 0, that is Gibbs free energy, standard Gibbs free energy. This 0 indicates standard state. We'll study later on. So this standard Gibbs free energy will be less than 0. Yes or no? Because you know when the work is spontaneous, delta G 0 will be negative. Similarly, work is here non-spontaneous. Why your work is non-spontaneous? Because in electrolytic cell, we have to supply the current. If you don't supply the current, if you don't give the electrical energy, chemical reaction will not start. So here, electrical energy is required to start the chemical reaction. So electrical energy is required to start the chemical reaction. Means electrical force, electrical energy should be supplied. Means without that, work will not done. Work will not be done. So work is here non-spontaneous. Due to this, delta G 0 will be greater than 0. Okay, you can copy out or you can take a screenshot. Then I move to the further topics. Okay, now we will see one topic. I hope you have copied it. Okay. See here. So next topic comes, and the name is you can write down the topic name electrodes. We'll understand this. Okay. What we'll understand? First we'll understand electrode. Then we'll understand electrolytic cell. Sorry, electrolyte. And you know, most of the student knows this. Okay. So electrolyte. Then we'll see types of. This can be asked for 2 to 3 marks in the exam. Okay. So see, first we will see electrode. What is an electrode? Nothing. It's a simple one metallic rod. That rod can be of zinc or that rod can be of copper. It can be of non-metal like graphite also. Okay. So this should be dipped in its salt solution. See, in electrochemical cell, we have seen that zinc was dipped in zinc sulfate solution. So that zinc, that metallic piece, that metallic rod was nothing but a what? Electrode. That's it. So what do you mean by electrode? An electrode is nothing but a what? A small metallic piece or a non-metallic piece which is dipped in the electrolytic solution. So you can note down electrode. A small metallic. See here I am telling piece. In book they have written strip. 1 and 7. Strip means a small like this. Very simple. Okay. So a small metallic strip which is dipped in its salt solution. Okay. Why I am telling this? See, last class we have seen the electrochemical cell. In electrochemical cell we have seen that zinc was dipped in zinc sulfate. So zinc was acting as their electrode. So zinc was a very small metallic strip. Okay. So that small metallic strip which is dipped in the salt solution. Now what is the role of that? What is the use of electrode? So use of electrode is what? This electrode undergo oxidation or reduction, or they provide the space or provide space. I will tell you detail, or provide space for oxidation or reduction. See, in electrochemical cell, these electrodes only give the space, give the room to undergo the oxidation or reduction. Without electrode, this reaction like oxidation reduction is not possible. So electrode should be there. So electrode is a what? Is a small metallic strip which is dipped in salt solution, which will perform the reaction, undergo oxidation reduction reaction. Or if they do not undergo itself, so they will provide the space. They will provide what? They will provide the space for oxidation and reduction. So you can make a note, write down the definition, exact definition. A metallic strip dipped in aqueous salt solution, and which provide the space or surface, for oxidation and reduction. I hope you written. Okay. So what do you mean by electrode? A small metallic strip, this much strip, or it can be a very big strip also. Okay. So a small metallic strip which is dipped in the salt solution, and that metallic strip will provide a space for what? Either for oxidation or reduction reaction. Okay. So in electrochemical cell or in electrolytic cell, oxidation reaction or reduction reaction occurs at where? At this electrode. Okay. This electrode. This electron can be metal also. It can be non-metal also. Okay. See, metallic electrode you can take any. Zinc, you can take copper. These are all metal electrode. Okay. You can take here Ag, yes or no, aluminium, etc. Non-metal you can take graphite. Yes or no? Here, carbon rods. It will come in future classes. Carbon rods. So these are the electrode. Here, now we will see electrolyte. So what is an electrolyte? Very simple. An electrolyte is a solution which conduct electricity or which allow electric current to flow through them. Yes? So what do you mean electrolyte? See here. So electrolyte is a solution. Which conducts electricity, or you can say which conducts the flow of electron. Okay, or you can write down another definition, a very simple definition, or you can make it heading, so we can note down. Electrolyte is a solution which allow the electric current to flow through them. Yes or no? We are taking zinc sulfate solution. Yes or no? Last class we have taken, no? We have taken the zinc rod in a zinc sulfate solution. That zinc sulfate solution is nothing but a what? Electrolyte. Why? Because that zinc sulfate solution will allow the electrons to flow through them. Okay. See, metal, you say conductor. You know conductor definition? We say conductor is a metal or is a solid which allows the electric current to flow through them. So for a solid piece, we are giving the name as a conductor. But for the liquid, we are giving the name as a electrolyte. Simple. See now, see what I mean to tell is, see for example, from in any solid state, so you can say aluminium, you can say copper, you can say zinc, that are the solid in state, or you can say graphite. In such a solid state substance, there is a passage of electron. They will allow the electron to flow through them. So such a solid substance we are saying as a conducting or conductors. Clear? But if there is a solution, liquid solution, aqueous solution, they will allow the electric current to flow through them. Then what the name we will give? We cannot say conductor because they are in liquid in state. So when they are liquid in state, we have to say electrolyte. So any substance which allow the electrons to flow through them, solid state, conductor. Same, liquid state, electrolyte. Okay. So clear this part? So electrolyte is a solution which conduct electricity, or electrolyte is a solution which allow the electric current to flow through them. Okay. Example, you can write down salt solution, or you can, one thing more, electrolyte always will be made usually through ionic substance. These are the, we have studied, I hope, in the equilibrium. We are not going deep. Just remember, electrolyte is a solution which conduct what? Electricity. Okay. Or is allow electric current to flow through them. Clear? Okay. So next topic we will go, that is type of electrode. You can copy out or you can make a pause and take a screenshot. Okay. See, many a time the questions are coming in the exam, and the question is very near about for 3 marks. And the question 3 marks or 2 marks, and the question is define electrode and explain the type of electrode. Okay. So these two questions are combining and coming in the exam. So we will see now type of electrodes. Clear? Okay. Now type of electrode, there are 3 types of electrode. First, active metal electrode. Okay. Second part is, you can say inert electrode. Third, you can say gaseous electrode, or you can say gas electrode. Right on gases. Okay, we will discuss this one by one. Write down this, make a note. Okay. So here we will see type of electrode. I told you electrode means what? A metallic strip which just undergo oxidation or reduction, or they will provide the space for redox reactions. Okay. Now we will see in detail. See, first we will see this active metal electrode. See, active metal electrode means this electrode, they will undergo oxidation. They will undergo oxidation means after the completion of reaction, the weight will be either reduced or weight will be either gained. Okay. So write down here active metal electrode. You can write down metal electrodes such as metal electrodes such as zinc, Ag, Au, which itself undergo oxidation or reaction. See, they itself will do the reaction. They itself will undergo oxidation or reduction. Okay. Write down active metal electrode such as zinc, silver, Ag, Au, which undergo the oxidation or reduction. They will undergo itself means what? Suppose if zinc is acting as an anode, so after the reaction, zinc weight will reduce. The weight will not remain same means it itself is undergoing the reaction. It itself is doing the reaction. Okay. Whereas if it acts as a cathode in certain case, after the completion of reaction, its weight will increase means it has done a reduction on it itself. So they will provide, or they will itself undergo oxidation and reduction. Active metal electrode. Okay. See, when I will do the inert electrode, we will clear in detail. Inert electrode. Inert electrode means what? These are, if you write two best examples. First remember the two best examples, that is graphite and platinum. See, now what happens? Inert electrode is an example. Inert electrode will also undergo oxidation and reduction, but they will not undergo itself. They will just provide the space. They will just tell the metal to get oxidized or to get reduced. After the reaction, the change in the mass will not take place. See here in active metal electrode what happens? That if I am taking a zinc as anode, so zinc after the reaction their weight will be reduced, or if zinc was acting as a cathode their weight will be gained. So these are known as an active metal electrode. Okay. For inert electrode, if I take graphite, so after the reaction either graphite has done oxidation or graphite has done reduction. Weight will not change. Weight remains same. Weight remains same means what? They are just providing a space, a room to do the reaction. Similarly for the platinum. So inert electrode. So these are the electrode which only provide space, provide surface or space to do reaction, do oxidation or reduction. Okay. Here, so what is the basic difference here? Here, they itself undergo. They will get lost. Weight will reduce. Okay. They are giving their sacrifice to do the reaction. Who? Active metal electrode. They will get sacrifice. Sacrifice either they will sacrifice by either by losing or by gaining. Here, no sacrifice is done. No sacrifice. In graphite and platinum, they will do oxidation. They will do reduction. But there is no sacrifice. Just they will provide a space. They will provide a surface. Come here, do oxidation or do reduction, go back. Weight remains same. But they are giving here sacrifice. Who? Active metal electrode. So when they are giving here sacrifice, so either their weight will reduce or their weight will be gained. When weight will be reduced, if they are acting as an anode, or similar electrode if they act as a cathode, so their weight will be increased. So we can say this as active metal electrode. Whereas in inert electrode, as the name indicates, no, inert. Okay, no reaction. Means they will just provide a space, one room to do what? To do the reaction. But they will not undergo itself oxidation or reduction. They will not give sacrifice. Here they will give sacrifice. Clear this part? So write down the inert electrode definition, or you can write down a book sentence, exact definition. Atom of such electrode. Madam, so for inert electrode, write down definition. Ready? Okay. Atom of such electrodes do not undergo oxidation or reduction. They provide only a space or surface. They provide a space or surface. They provide a space or surface for oxidation or reduction. For oxidation or reduction. Thus, if they do oxidation, act as anode. If they do reduction, act as cathode. Okay. So I will write down one example here for this for better understanding. See the example. If I have Fe plus 2, okay. So Fe plus 2, if it is converted into Fe plus 3, okay. So first I am giving this equilibrium reaction, okay. So here Fe plus 2 is converting into what? Fe plus 3. So you can see here the electrons will be lost if I go in this manner. Yes or no? If I consider forward reaction. So this is one thing, but what? Oxidation. Yes or no? But if I consider the reverse reaction, see Fe plus 3 is gaining one electron and converting into what? Reduction. Yes or no? And this whole reaction takes place on what? Platinum strip. You can write down here. This reaction has happened on what? Platinum strip first. Here, if it is going, it is oxidation because loss of electron. Reverse case, reduction. And this reaction has been done on what? Platinum strip. So platinum strip come under what? Inert electrode. After the reaction, there is no change on platinum. There will be change in the ions. If oxidation would have occurred, Fe2 plus will be converted into Fe plus 3. If reduction would have occurred, so Fe plus 3 will be converted into Fe plus 2. These two, both the reaction can occur only on one state, that is platinum state. But after the reaction, there is no change in the platinum state. That's why I say as a what? It's in a clear this part? We're done. Okay. So next